Good day, sir. We are the Group 7. We will present to you our topic. So, our topic is proportional control. What is proportional control? Control system based on a response in proportion to the difference between what is set as a desired process variable or set point and the current value of the variable. Second, use where maintaining a process variable to a tighter tolerance and timely responsiveness are required. Third, involves fine grain control through a feedback mechanism. Susutil.
Ay, what is a flow control? Flow control is a mechanism that ensures the rate at which a sender transmitting is in proportion with receiver receiving capabilities. 2. Flow control is utilized in data communication to manage the flow of data package among two different nodes, especially in case where the sending device can send data much faster than receiver can digest.
Flow control of a pump. To understand how a flow control loop works in real life, consider the flow control mechanism of a centrifugal pump. As for our example below, we have the centrifugal pump which has a minimum flow rate of 100 cubic meter per hour. Pumps that require minimum flow rates are mostly pumps with a horsepower between 10 to 30 HP. Since our set point is past the required flow, there will be no problem regarding the circulation loop. If in any case our set point is below the required flow rate, the control valve or the sensor will detect the error and send the signal to the controller. The controller will then activate the error and the flow will be sent back to the inlet to satisfy the minimum flow condition of 100 cubic meter per hour.
So next is the proportional integral or the PI control. PI control is the form of feedback control. It provides a faster response time than I only controls due to addition of the proportional action. PI control stops the system from fluctuation and it's also able to return the system to its set point.
So let's proceed to the scenario. So if the set point is set to 60,
Degree.
60 degrees Celsius, then we can say that the output is also 60. And if the actual flow is 30 degrees Celsius, then we will subtract 30 degrees Celsius to the output, which is 60 degrees. And we will get 50% error signal. Then the proportional integral controller will take action to the remaining 50% also to complete the process.
So let us now move on to Group 8. So our topic is Proportional Derivative Flow Control System. So you read by Suitado.
So, proportional derivative flow control system is a type of controller in a control system whose output varies in proportion to the error signal as which the derivative of the error signal is known as the proportional derivative controller. It is also known as proportional plus derivative controller. So next guy. Flow controllers are mechanical or electromechanical devices composed of measuring sensors or controlling elements that are used to ensure the media flow in manufacturing processes. They are made for gases as well as liquids of many types and are available to many sizes and configurations depending on the application. The presence of a derivative control action with a proportional controller enhances sensitivity. This helps in producing early corrective response for even small value of error signal, thereby increasing the stability of the system.
So this is our
So this is the
diagram. So this is our diagram. So we have the set point and then the error and then the PD controller or what we call proportional derivative controller and then the motorized valve and then the output and then goes with the flow sensor and then go back to the error and then the next is you read by Victor.
When the first the controller monitors the water pumps out flow in real time, feeds it back to the controller. The controller reacts to the flow value. When derivative control is applied, the monitor input current frequency can be changed by controlling the inverter. The flow control system senses the rate of change of the error signal and contributes the components of the output signal that is proportional to the error signal through the real-time monitoring of the output flow and the real-time regulation of the monitor.
So this is other example of diagram. So as we can see in the PID controller part, so only the proportional and the derivative is connected because we only use the proportional derivative controller. So we have here the digital multimeter and then the set point and we also have here the motorized valve driver. So let's now move on to PID or what we call proportional integral derivative flow control system. So PID. So proportional integral derivative flow control system. So you read by Villaril.
Convoy present. So good morning, sir. So proportional integral derivative flow control system. So ang PID control provides a continuous variation of output within a control loop feedback mechanism to accurately control the process, removing oscillation and increasing process of efficiency. So PID control is a well-established way of driving a system towards a target position or level. It's a practically ubiquitous as a means of controlling temperature and finds application in myriad chemical and scientific processes as well as automation. PID control uses closed loop control feedback to keep the actual output from a process as close to the target or set point output as possible.
So this is our diagram. So we have we have here the set point, the error, and then the PID controller or proportional integral derivative controller, and then motorized valve, and then the output which is valve open, and then the flow sensor, and then go back to the error. And then the next is URID by Sambangnon. So Sambangnon.
It is important to change the open loop system to a closed loop system by implementing a controller so as to control the stability of flow rate by controlling the vibration in the motor. Flow control system is a basically feedback control system. Control system which is a closed loop system. If there is unwanted vibration in the motor, the stability of the rate will hamper.
So this is our another example of diagram. So as you can see here in the PID controller, so it is all connected, the proportional, integral, and derivative. We also have here the digital multimeter, and then the set point, the motorized valve driver, and the flow sensor interface. So that's all for Group 7 and Group 8 flow control reporting. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Pila ka minutes